Hi girls, today's video is on domain and range, but first there should be a quiz question or two there to check what you understood from today's lesson. Okay, so domain and range. So basically, domain and range, if I have a function, or in fact a relation for that matter, hopefully you know the difference by now, and I draw something. Okay, so there's my function. I seem to default to drawing cubics for whatever reason. So basically, the domain here is all of the x values that are taken in the function. So for a cubic, the domain is all values of x, because for a cubic, you know, it might be something like y equals x cubed plus 3 or something. I don't know. And the point is basically that no matter what x value I tell you, you can calculate x cubed plus 3. Okay. Whereas, if I look at a different function, and I look at the square root of x, in this case, the domain will be all positive values of x, including 0. Because you can take the square root of all positive numbers, including 0, but you cannot take the square root of negative numbers. Oops. Similarly, the range is all the y values. And you think of it as the y values that the function achieves, right? So again, if you look at a cubic like this one, the y values are all real y, right? Every y value will come from a cubic. And you can think about that by drawing horizontal lines across, because these are y values, and seeing where the curve hits it, right? And if it does, then it's achieved. If I look at this one here instead, and think about the y values, so y equals the square root of x, by definition that is positive. So the range is all positive values for y, including 0. Okay? And again, generally speaking, if I can draw the function, which I can, that is the easiest way to look at the domain and range, right? Look at where it's drawn. It's drawn for all positive values of x, so that's the domain, and it achieves all positive values of y, so that's the range. Okay? Before I show you any other examples, I want to show you some notation. So we can write, instead of saying x is between a and b inclusive, we can write this. X is included in the interval, closed interval, a to b, right? Closed interval means it includes the endpoints. Right, so here's my number line. Here's A, here's B, and the solution is from there to there with a closed circle at each end, right? So you read this as x is in the closed interval A to B. Oops. Another thing you could write is like x between A and B without the endpoints, in which case you would write x is in the open interval A and B. And if you close at one end and open at the other, then you can probably guess closed at one end, open at the other. And the last case, or the last two cases are, let's say x is greater than or equal to b, then that x is in the interval from b all the way up to infinity. Open, right? Infinity is always open because it's not a number. And if you do like x is less than a, you'd have x is in the interval minus infinity, again open, up to a, and open because it's less than or not less than or equal to. Okay, so let's say we've got this function here, right, and pretend that I was better at drawing and the maximum value is actually at 8. Then in this case the domain is the x values greater than or equal to minus 2. And the range is the y values less than or equal to 8. Okay. Here's another example. So another example. Let's draw a hyperbola in purple. first time I've done purple today, look at that. So there's my asymptotes. Let's pretend that's 1 and that's 2. And so the domain is x not equal to 1, and the range is x not equal to 2. Okay, those are pretty simple examples. Let's do one more together. So let's just think about the function y equals the square root of 5 minus x. I'm going to do it two ways. I'm going to do it algebraically and I'm going to do it visually. So here's visual. I draw it. It looks like that. Right? It's the top half of a sideways parabola shifted across, oops, that should have been a 5, not an x. Shifted across 5 units. So I can say from that that the domain excuse me, is x less than or equal to 5, which I can also write in another notation, and the range is y is greater than or equal to 0, which again I could write in another notation. Right? Another way to do it is to say, for the domain, you kind of build on a restriction. So because I'm taking the square root of 5 minus x, it only makes sense if the thing that I'm taking the square root of, 5 minus x, is positive. And now I've got an inequality to solve, and I'll skip a step because I know the solution. But it is the less than or equal to 5, right? Similarly, this is by inspection, you look at it and you say, well, I'm taking the square root, so that means y has to be positive. Okay, so we don't need the visual. Here's another example that builds on that, despite the fact that I said that was my last example. I can hear your whinging and moaning, and I don't care. So y equals the square root, 1 on the square root of x minus 5, so let's pretend we don't know how to draw it, right? And let's do it algebraically. So for the x values, the restriction is that I'm taking the square root, so it must be positive, but I'm also dividing by it, so it must be strictly positive, not 0. And so that tells me that x is bigger than 5. And then for the y values, so that's the domain. For the range, firstly, I can see that it must be greater than or equal to 0, right? But there's more than that, right? Because I can't actually include the 0. Because it is a 1 divided by, there's no way for that to ever equal 0. Right? And even more so, you can kind of build the function to do it properly. You can say, well, I know that the square root of x minus 5 is greater than or equal to 0. And then when I take the reciprocal, I will get all positive values. Because if you think about what this is, it's 1 divided by all positive numbers. Right? So if the numbers are big, I'll get really small numbers. If the numbers are small, I'll get really big numbers. Okay? But basically, if you can understand it intuitively like we did here, that is the best way around it. Okay, so that's all for tonight. Tomorrow's lesson will hopefully reinforce anything, especially this last one, which is reasonably complicated, but we can certainly do some more like this together tomorrow. Alright, have a good night.